Okay guys, I'm going to be discussing to you right now a very popular application of algorithms, and that is in sorting. Okay, there are a lot of sorting algorithms out there, but we're going to be focusing on two of them today. It's bubble sort and that of insertion sort. Okay, so to give you an idea, what is bubble sort? It is one of the simplest sorting algorithms as said on the text. Okay, there's a reason why it's called bubble sort. Okay, but I'll defer the explanation as we go along the given examples. Okay, so example 4 on your copies will tell you that we're tasked to do bubble sort on the following numbers 3, 2, 4, 1, 5. We're tasked to try to sort this out in increasing order. Okay, probably we're just going to be focusing on figure 1. Okay, let me just have this given to you as such. Okay, so I'm going to be introducing to you the concept of pass, algorithm passes. So as you can see on the figure, there's the first, second, third, and the fourth pass. The passes of the algorithm dictates the number of times we apply the algorithm to solve the problem. So there will be variations on the given input, okay, that we had every time that the algorithm is applied. So there will be, let's say for instance, when I apply the algorithm for the first time, the output of such will be the first pass. When I apply the algorithm the second time around, it will be the second pass. So we're going to try and look into the details on what is happening or how the numbers are sorted out from one pass to the next. Okay, so let me explain to you how this diagram works. There's actually a legend here. Whenever you see this symbol, there is an interchange that will take place, and whenever you see this symbol, the pair is in the correct order already. Okay, so let's try to look into this one now. So as you can see on the first pass, on this on the leftmost side, this is actually the given. Okay, 3, 2, 4, 1, 5. So the algorithm dictates in bubble sort that we have to compare first the first two. Okay, as you can see from the symbol, there is an interchange that will take place because 3 is greater than 2. So our target actually is to drag the larger numbers downwards, and then the smaller number should remain on top. Okay, so there should be an interchange because 3 is greater than 2. 3 will be transferred here, as you can see on what happened. Okay, now since there was an interchange, okay, and we're looking into the greater number to be dragged down there, so 3 will now be compared to 4. Okay, since it's in the proper order already, on the next time we apply the algorithm, we are now going to be focusing on 4. 4 will then be compared to 1. Since 4 is greater than 1, there will be an interchange. And then 4 will be here. And then 4 will be compared to 5. As you can see, no change at all because they are in the proper order now. So what did we accomplish using the first pass? So the first pass, by the way, is 2, 3, 1, 4, 5. On exams, I would like you to specify the first pass as is. As you can see here, okay, this is our given. Our first pass, the result of the first pass is 2, 3, 1, 4, 5. You have to list this down every time we have an exam. I will be asking you to do this. Okay, indicate the first pass of the algorithm accordingly. So we were able to apply the steps, and this is actually our answer for the first pass. So what did we accomplish on the first pass? I don't know if you were able to see, but we did accomplish one thing. We were able to put the largest number at the bottom. Okay, the largest number has been placed at the bottom part. So that's why in this demo, I highlighted 5 as the result of the first pass. Again, we were able to produce the largest number, and it's permanently there on the last part of the list. Okay, so again, this is your first pass. Recursively, we're going to apply the algorithm again. We're going to be looking into the second pass. The second pass will, of course, use the output of the first pass. So 2, 3, 1, 4, 5 is here. We're now going to apply the algorithm recursively. So 2 will be compared to 3, no change at all. 3 will be compared to 1, there will be an interchange. 3 will be moved here. 3 will be compared to 4, and as you can see, there will be no change at all. Okay, we're not going to be comparing 5 anymore. Why? Because we were able to distinguish the fact that 5 is already the largest number, so no one could beat that anymore. So they're actually isolated, thus the box. Okay, so we were able to accomplish on the second pass, we were able to give the second to the largest number here, and we determined that it's actually 4. So what's the output of our second pass? 2, 1, 3, 4, 5. And on exams again, you will have to specify that on the list. 2, 3, 1, 4, 5. 4 and 5 has been established already. Next pass, the third pass will make use of the output of the second pass. 2, 1, 3, 4, 5, as you can see here. We compare. 2 will be switched with 1, and then 2 compared to 3. Again, we have established already that 3 is the third largest element. So the output of the third pass is 1, 2, 3, 4, and 5, as depicted here already. Okay? Now, notice that the list is actually sorted already. Okay? Yes, we could actually see that with our own very eyes, right? But the computer doesn't know that. Okay, so the computer has to apply the algorithm for one more time. It has to continue with the steps left to perform the algorithm. So we will have to have a fourth pass. Okay, the fourth pass uses the third pass output. So 1 and 2 will then be compared, and there will be no change at all. Okay, thus we're left with the conclusion that on the fourth pass, we were able to solve the algorithm. So it gave us the idea that the fourth pass, or the final pass of the algorithm, was able to solve the problem, which is 1, 2, 3, 4, 5. Okay? So how many passes should there be? It depends on the problem. Okay? In this particular problem, I was only able to use 4 of them. Okay? But on some problems, there could be 8, there could be 10, there could be so many passes. That's why you have to determine, or you should always be listing this down when I ask that on the exams. Okay?